Welcome back to our channel. In this video, we'll be exploring the best practices for Docker image size and container security. Docker has transformed the way we deploy applications, but to ensure optimal performance and protection against vulnerabilities, it is essential to implement efficient image management and robust security practices. So let's dive right in. When building Docker images, the size of the image is an important consideration. To ensure reliability and trustworthiness, it's recommended to start with official and verified Docker images as your base image. Choose a smaller, more lightweight base image that includes only the necessary components for your application. For example, we could use simple Python 3.9 slim version as the Python runtime for your base image, like in this example below. Doing so can help you avoid potential security issues and reduce the risk of system failures. In order to use official images, you can specify the name of the image, like we did just now, in your Docker file, and then Docker will automatically pull it from the official registry. This is a best practice that will not only help you create more secure and reliable images, but also save your time in the long run. When creating Docker containers, it's important to specify the exact version of the base image being used. This helps to prevent unexpected changes and inconsistencies that may arise from using different versions of the same image. To do this, you should include the exact version of the base image in your Docker file. So previously, we only had from Python 3.9-slim. We will update this to a more specific version of the base image, which will be, in this case, from Python 3.9.10-slim. When making Docker images, it is important to keep the small size for better efficiency and, of course, disk space. To do so, we can use two methods in this case. So the first one is optimizing caching image layers and using a Docker ignore file to really leave out the unnecessary files. So when talking about optimizing caching image layers, what it actually means to us is that we'll be dividing the image into smaller parts that can be cached alone. This way, when we make changes to the code, only the modified parts need to be rebuilt. This actually saves a lot of time and makes the final image really smaller comparing to the other one. So how we can do this? For example, in this specified file, we would include copy requirements.txt to a directory, let's say called app, for only copying the necessary files, and also specifying the dependencies we would like to install with our application, such as run pip install, and then we'll use -- no cache dir, and then specifying also the requirements.txt. It's important to also keep in mind that each time we run specify the run command in Docker, it will create a new layer to our image, which can increase the overall image size. To minimize the number of layers and reduce the final size of the image, it is advisable to combine multiple commands into a single run statement using the n symbol twice. So this is how it looks like in the example below. And it's also worth noting that when using Docker ignore file, it can help us out leave all the unnecessary files out from our image. Things like log files, configuration files, temporary files that aren't really needed for our application to work. And this makes the image even smaller and speeds up the actual build process. So here's also an example for you guys of how a Docker file or Docker ignore file, could look in practice. So in this example, we have files such as .git, let's say VS Code, something that we could come across on a daily basis, considering using Visual Studio Code, or any other files with extension .log are going to be ignored as they're part of the Docker ignore file. Also, directories such as, let's say, node modules, commonly used for Node.js projects. You'll probably see them in the future. And also at the same time, the Python bytecode cache, so the PyCache, are equally ignored. And once again, this helps to keep things tidy, removing all the unnecessary files and directories out of our Docker image, reducing its size and really improving in the build times. By using these tips, we can create Docker images that are even more efficient and take up less space. So this makes it easier for us to install and manage them in different environments. When building Docker images, it's often a good practice to use multi-stage builds. What does this approach mean? So it can significantly reduce the size of the final image by separating the build dependencies, which are only needed during the build process, from the runtime image itself. So let's see how this looks like in the example below. As we can see here, by using the multi-stage build, we can keep the final Docker image size small. So in the first stage, as we can see from where we specified the Python base image, we've included all the necessary tools and dependencies to build our application. Once the application was built, we only copied the built artifacts and necessary files into our final stage, where we've again specified in the comments, let's say different environments such as production or wherever else you would like to be deploying it. This will help to also minimize the size of the final image of the final product, as it will only contain the runtime dependencies needed to run the application. When using container technologies such as Docker, it is important to prioritize container security. Container security involves taking steps to protect containerized applications and their underlying infrastructure from potential threats and vulnerabilities. In this particular section, we would like to dedicate a bit more time in discussing key considerations, best practices, and of course, recommendations for container security. When we use containerized environments, we need to make sure that each container is isolated from the others and, of course, the host system itself. This is important because it helps prevent unauthorized access and reduces the damage that could happen if one of the containers got compromised. To achieve the isolation, we can use different security methods such as namespaces and cgroups. If you'd like to learn more about this, please make sure to watch our YouTube video specifically made for this. To keep your applications secure, it is important to use a non-root user when running your containers. This simply means creating a user account specifically for your application and using it to run the program. So by doing so, you can reduce the chances of unauthorized access to your system which will give an extra layer of security and really help prevent malicious attacks. It is also important to note that using a non-root user can help minimize the potential damage if your application was to get compromised. So always remember to use a non-root user account to ensure the safety and security of your application. So let's see how this looks like in the example below. So we'll use the similar structure of our Docker file, specifying the Python base image of 3.9, and then underneath we will use the run command to add additional commands, where we'll be adding a specific group for our, let's say, headintheclouds user, and also assigning them specific permissions to be able to, of course, use that later on. So the Docker file itself, we've created the non-root user, apologies, for headintheclouds user using the user add -m headintheclouds user, and then later, after the set of the usual commands, the build steps that we've included in the Docker file, we have also specified to switch to that user using the user headintheclouds user at the very bottom of the Docker file. As you can see, the rest of the Docker file itself follows typical practices for building and running Python applications, so including the copying of the files and so on. Therefore, by implementing this practice, you can significantly reduce the attack surface of your containerized environments and mitigate the risk of potential security breaches. Essentially, this means that you should always avoid running containers with root privileges and instead use a non-root user with the minimum permissions required to operate the application. This helps to limit the amount of damage that could be caused by an attacker who could potentially gain access to the container, as they would only have access to the minimal set of resources required by the application to function. When managing Docker images, version control is crucial for maintaining a clear history of changes and ensuring the availability of the latest version. This can be achieved using Git, which is a widely used version control system. By creating a Git repository for your Docker files and related scripts, you can track changes, manage different versions, and collaborate with team members more effectively. To ensure that each version of your Docker image is properly tracked, you can use Git tags or branches to label different releases. For example, you might tag your Docker file with version numbers such as version 1.0 or version 1.1 and so on to indicate different releases. We'll be doing a demo on this in our upcoming videos, where we will be doing the CI specific exercise demo with Docker itself. When it comes to storing and managing Docker images, utilizing a secure container registry is always highly recommended. So places such as Docker Hub, of course, Amazon ECR or Elastic Container Registry, GCR stands for Google Container Registries, and so on. It's always good to look into these solutions to provide secure and reliable storage of your Docker images. So if you'd like to check more about this, please do make sure to watch our videos specifically dedicated to this topic. In the context of containerization, the concept of immutable infrastructure refers to the practice of treating containers as immutable units. This means that once a container is built and deployed, it should not be modified in any way. Instead, any changes or updates should be made by creating a new container from an updated image. This approach ensures that the infrastructure remains consistent, predictable, and easily reproducible. It also helps to minimize the risk of errors and inconsistencies that can arise from manual modifications or updates to our running containers. By enforcing immutability, containerization enables greater scalability, reliability, and efficiency in modern software development and deployment practices. By performing regular image scans with Trivy or similar tools, you can proactively identify and address security vulnerabilities in Docker images, helping to secure your containerized applications effectively. So for this demo, let's create a simple demonstration or practice to scan a Docker image using this tool, Trivy, a popular open source vulnerability scanner for containers. First, it will be good to check on your system that you already have Trivy installed. So you can follow the provided link here below for the installation instructions directly from their GitHub repository. Once it's installed, you can use it to scan Docker images for vulnerabilities. Firstly, you could pull a Docker image. In this case, we'll use a Python image as an example. So you can just specify this in your terminal. So we'll run a command docker pull and then Python 3.9-slim. And then you can scan the Docker image with Trivy. So scan the actual pulled Docker image from vulnerabilities. The command for this will be Trivy image Python and then specify the version of the selected app itself. And then the actual tool, Trivy, will analyze the image layers and in case of any vulnerabilities are found, report back along with their severity levels. Once you get the outputs, examine the scan results provided by the tool. The outputs will include all the information needed for each vulnerability detected, such as specific CVE IDs, severity levels, package names, and descriptions. So here's an example of what we have found for this specific version on our local machine. So based on the scan results, the next steps, you could take appropriate actions to remediate these vulnerabilities. This will also include updating your packages, ensure always to be running the latest versions, applying the required patches, or using alternative images with fewer vulnerabilities. You could also integrate the tool itself, the scanning, into your CI/CD pipeline to automate vulnerability detection for Docker images. You can use also the Trivy's CLI or its client libraries to incorporate scanning into your existing automation workflows. To keep sensitive information secure and maintain the overall security of an organization, access controls need to be applied for both container management and container data. Access controls limit who can access containers and the data, reducing the risk of unauthorized access and, of course, cyber attacks. By implementing access controls, organizations ensure only authorized personnel can access containers and their data. Access controls also help organizations monitor and track who accesses containers and the data. When managing containers, it's best to use a role-based access model, or better known as RBAC, to limit access to platforms, for example, something like Kubernetes. This way, users can only be given the minimum permissions necessary to accomplish their work, reducing the risk, once again, from unauthorized access and potentially security threats. By using RBAC, specific roles and permissions can be assigned to users based on their duties, and they are only granted access to resources or environments they need. This method allows for better control over your container system, as we can see in this diagram above, and also helps to avoid accidental misconfigurations or undesirable access that could lead potentially to security breaches. When storing and transmitting sensitive information, it is important to make sure and take measurements to protect them from unauthorized accesses. So one way to do this is by encrypting the data both when it's at rest, so what this means is being stored on a server or on a device, and when in transit, so being transmitted over a network. Encryption involves using a mathematical algorithm to scramble the data so that it can only be read by someone with the key to unscramble it. By encrypting your container data, you can ensure that even if it falls in obviously the wrong hands, it will be unreadable and therefore useless to anyone who doesn't have the proper authorization to access it. We have come to the end of our detailed discussion on Docker image size best practices and container security. In our upcoming video, we'll be covering a highly requested topic by you guys from our community, and that is Docker networking. If you found this information that we shared in this video helpful, we would appreciate it if you could like, share and subscribe to our channel for more content on similar topics. Thank you for watching, and we look forward to seeing you in our next video.